I'm delighted to say that presenting this webinar alongside myself is Dr. Tim Sandle of BPL. Tim is a world-renowned speaker and published author on microbiology, sterile manufacturing, contamination control. Tim works at the BPL sterile manufacturing facility based in the south of England. As there are more than 100 people dialed in today, I would like to ask that you submit your questions through the question function of the webinar, and I'll pose these to Tim at the end of the presentation. Both going to turn our cameras off while presenting to hopefully avoid any bandwidth issues, but we'll return at the end for questions. So with that introduction complete, I'd now like to hand over to Tim and we'll start the presentation.
Okay, thank you very much, and it's a great pleasure to be with you today during this webinar. So we're going to be talking about contamination control strategies and how this fits into the cleaning and disinfection piece. Okay, so what we're going to be covering today in this webinar is, first of all, we're introducing what is the contamination control strategy, what are the fundamentals that we need to be considering, and then how this fits in with cleaning and disinfection. So for that, we need to understand contamination sources, the areas that we need to focus on, and then we'll be looking at how we can apply a tool to help us to assess the contamination risks, and that'll be in the form of a case study with a particular focus on material transfer and also with the management of residues. So this is the quotation for the contamination control strategy. And I just want to call out some of the words that are most pertinent. So the first thing is controls, and this is really important because microbiological monitoring methods are relatively limited in terms of the size of the samples that can be taken and with the accuracy of some of the instrumentation and the fact that a lot of microorganisms are simply not culturable. So we need to get the best controls to minimize contamination risks in place, and we can't overly rely upon monitoring. The next thing is that obviously contamination in this context is with viable microorganisms, but also with pyrogenic substances, of which endotoxin is going to be the primary one, but also with particulates, because sterile products need to be free of, liquid sterile products at least need to be free of visible particulates. And we can only achieve this by understanding our product characteristics and understanding the nature of our processes, how we move from A to B and the various steps in place, the supporting parameters as well. So monitoring is important, but so is control. And part of what we're going to be talking about today is how we tighten up control and make it better. So in terms of a little bit more detail about the contamination control strategy, it is a system, and by system it means that it's systematic. We've broken everything down into its core stages, and we've looked at every element, but also we're looking at how these link together. We're looking at the bigger picture, and one of the key kind of buzzwords in this context is holistic. So we need to be mindful of, say, what's happening in a grade C clean room and the potential impacts that could have in a grade B area, for example. And we've already mentioned quality risk management, but these principles are really important for helping us understand things like what's the potential for contamination being there for a particular hazard of concern, and then what's the severity that that hazard presents. So should it get somewhere else in the environment? Should it be transferred by a person or an object? What's the chance of it getting into product or onto a product contact site? So the whole likelihood piece is also of importance. And in terms of some of the core elements, we've obviously mentioned microbial contamination and particulate contamination. But we've also got the wider philosophy of sterility assurance, which extends from everything from the raw materials through to the design of clean rooms. For particular pharmaceutical products, we're going to have concerns around viruses, particularly for a range of biotechnological products. The design of the facility is very important, down to the level of the number of air change rates in clean rooms, the air distribution, how we transfer materials, which we'll be touching upon. Mix-ups is also something of concern. That goes down to the level of labelling through to cross-contamination and the reliance we might have on cleaning validation strategies, which also leads to cleaning as well, chemical contamination, where we may have residues in vessels, which we need to be mindful of, and through to the packaging as well, because the responsibility for making a medicine goes all the way to the point when the patient is in receipt of that medicine. So we need to make sure that both the primary and secondary packaging are sufficiently robust. There's also two key principles that we need to be mindful of. So one is that control should be driven by an understanding of technology and science. So we need to be able to sort of stand back and make sure that what we're proposing has a defensible rationale and makes scientific sense. And we can only really do this if we have sufficient knowledge of our processes and the risks that are presented. And then we need to make sure everything is organised and carried out consistently. And that's something that's not only a matter of procedures. Of course, we need good documents in place, but we also need to focus on the human elements as well, because the biggest variation to many of the things that we do is people and the way they behave. So human factors, the ergonomics, the understanding of the SOPs, the assessment of competences, the learning and education processes are all equally important for making sure that we can apply everything in a consistent manner. So finally, with the contamination control strategy introductory piece, perhaps the best approach to think about developing a strategy is to define process flows. So we're kind of mapping how people move around clean rooms, how objects get into clean rooms, where the activity takes place, where product is exposed. All of that type of thing is of great value. And we need to divide the strategy into various sections. So we will look at things like manufacturing plant, which could be our clean room design piece, our processes, particularly things like hold times, because hold times are always an opportunity for microbial growth. The premises, the people, level of gowning, behaviours, utilities, so quality of air, water, and so on. Raw materials, where we're sourcing these from and the types of testing. The containers we're holding our product in, the validation of the process, and then the core topic of this webinar, which is centered around cleaning and validation. And although we might present all of this as separate parts, one of the key things to bear in mind is that all of this needs to be drawn together and all of these elements are interlinked. So I'll now hand you over to Helen.
Thanks, Tim. So as Tim's just described, this this holistic, which is very much the buzzword being used with contamination control strategies, you know, it's all elements of your manufacturing process brought together to give you this wide view of contamination control and how your process is impacted, making sure that you're driving that quality right through your process that it's designed in. And one of the elements that's actually listed in the annex as a specific topic that should form part of your contamination control is cleaning and disinfection. So cleaning and disinfection, it fits into that process because it is a control step in the management of contamination risks. Because although we can do a lot of design, a lot of practices and procedures to try and reduce as much as possible that contamination does not enter our classified areas, but we live in the real world and we know that we can't eliminate all of that contamination coming in. It does make its way into the facilities. So where we want to think about a control strategy aligned to cleaning and disinfection is about trying to proactively control those contaminations coming into the facility by designing the cleaning and disinfection regime to deal with those. And the way we can do that is by thinking up front, what are the risks? So where are the points at which this contamination can enter the facility that we might need to treat it with cleaning or disinfection? And we develop that cleaning and disinfection regime aligned to those risks that we've identified. So going back to what Tim said there about sort of process flow, mapping out what's going on, it's taking that very detailed view of what are the activities are happening within the classified areas and where potentially may these contamination risks be present, that where a source of contamination is going to enter within the facility. It's worth bearing in mind as well that in the update to Annex 1, they were very clear about making a distinction between cleaning and disinfection as two distinctly different processes. So when we talk about cleaning, the type of contamination risks that we want to address with cleaning processes are physical or chemical contamination risks. So by physical contamination, we could be talking about the shedding of particles onto surfaces. So it could be shed through consumables that are used within the area that might shed out particles onto the surface. And we know from operator movement, even though they're gowned, there is a shedding of particles as people move around a facility. Or from a chemical contamination perspective, so this could be maybe process residues or spillages that you have from your process that could contaminate surfaces. But also, we need to bear in mind disinfectants and the types of disinfectants that are used also have the potential to leave a residue, a chemical residue on a surface. So cleaning concepts need to also think about the residue management, and we'll come back to that later on in the presentation. So for disinfection as a separate process, the contamination that's being dealt with by disinfection is microbiological contamination. So we're talking about the organisms that are potentially shed from humans, so your staphylococci, that kind of thing, or it could also be more spore-based ones, fungal or bacillus spores potentially entering the facility, and also possibilities of waterborne sources that maybe if you use water within your facility. So again, it's just thinking about all those different elements of where those microorganisms might be present within your facility based on how you perform operations, and then you can design that disinfection step to treat those potential presence of bioburden. So what I'd like to go on to now is to talk a little bit about Ecolab's Contamination Control Strategy Assessment Tool. So the technical team within Ecolab were all pharmaceutical, ex-industry microbiologists that are experienced in sterile manufacturing. We felt that we could sort of help our customers in this sort of daunting step of producing a contamination control strategy to act within our area of expertise to help identify these potential risks in the process and assess those. So we've designed an assessment tool that reviews your current practices, so gathering that process information of what's going on in the facility and assessing those against current regulatory requirements and also best practices. So we've aligned this assessment process to global regulations, and we're looking at as I say, it's aligned to cleaning and disinfection and decontamination. So we'll look through the material transfer processes, hand sanitisation, hydrogen peroxide vapor decontamination, the large and small surface disinfection steps, and also cleaning and residue management. So we can come to the facility, we've set it up as a digital tool to be as efficient as possible. We can walk around, we can capture, and so we can review that current state. But then we'll give that a risk score. So say, for instance, that there's a non-compliance to a regulation, then that would be given a high risk score and flagging that up to through the app. So what we can then do is obviously where those risks are identified, then with the solutions that we have, we can help mitigate those risks to bring down that. And then you get a document that provides this overall picture of your strategy of how you're managing cleaning and disinfection as your current state. But then as you mitigate any potential risks that are identified, you can update that document and show that you've moved to an improved state of control. So we worked with Tim at his facility. So I'll hand back for him to now introduce that to you.
Okay, thank you, Helen. So just a brief little bit of context. I work for a place called Bioproducts Laboratory, which is based in the UK, and it's a very large facility. It has 215 clean rooms, so there are some grade A zones, and there's lots of grade B, C, and D clean rooms. And it makes a sterile medicinal product that's based on plasma proteins, so it's an aseptically filled parenteral product. And particularly with aseptic products, there's no final treatment of the medicine in the container, so control of contamination is of paramount importance because there's no final step that can remediate if contamination gets into the product. And the processes are quite complex and they do rely on a lot of human interaction. And although there is a good contamination control history, as part of the drive for continual improvement, we felt it was prudent to ask Ecolab to undertake an assessment. And there were two areas that required particular attention, which we'll take you through. The first was around residue management, and the second was with material transfer. And with these two areas, they are of importance in relation to what regulators are saying. So if you have a look at FDA warning letters, which enter into the public domain, and we've put a few quotations up on the slide, but in particular, there's a strong concern, and this is also reflected in inspections carried out within the UK and European Union, that the transfer of items into a clean room, and particularly moving from one grade of clean room to another, is a major risk factor. And this is also called out in the revision to EU GMP Annex 1. So a primary contamination route is linked to this material transfer process. And then there's also increasing regulatory concerns about chemical residues left from the disinfection process. And there are some particular concerns about that we'll also be discussing. So with material transfer, so looking at the example on the slide, there's a transfer hatch, and then there's two people preparing to move something through. And because of the cascade of different clean room grades, we need to be reducing the bioburden. And then if we're using grade A, presenting the grade A with no, or theoretically no bioburden whatsoever. And there's a particular concern with bacterial spores through this process, and there are some historical cases, some relatively recent, where there have been contamination events linked to bacterial spores. So we need to be very mindful of thorough disinfection and other control measures to minimise the spore risk going into our higher grade cleanroom areas. So here, got a sort of a more simple representation of that process. So here we're moving from grade C into grade B using a pass-through hatch. And there are two key measures that we need to consider at this stage. One is removing a layer of wrapping, and the other is undertaking a effective disinfection step. And in the context of at least aseptically filled products, then this would need to be a sporicidal disinfection step. Now, in terms of transferring items into clean rooms, there is a number of different routes by which this can happen. So we could talk about a sort of hierarchy of contamination control. So the optimal way is by use of an autoclave, or where we have particular concerns around endotoxin with glassware, for example, then a depyrogenation tunnel that would be running at around 300 degrees Celsius. But a number of items can't be autoclaved, and also there's a push within the pharmaceutical industry to use single-use sterile disposable items as well. So these, and they're largely plastic items, would in some facilities with particular chambers, they might attempt an automated decontamination process, such as using hydrogen peroxide vapor. But commonly across industry, the pass-through hatches remain in commonplace, and there are two designs of these types of hatches. So there are those that we might call dynamic, which have HEPA filtered air supply, and interestingly, the revision to Annex 1 is signalling that pass-through hatches going forward should be fitted with HEPA filtered air. And then there are some static hatches as well. And with both of those items, whether or not there is a HEPA filter, that becomes one of the focal points of this webinar, is how we get those types of items into the clean room and the importance of disinfection. And at the bottom of the list, there's the someone carrying something through, such as through a changing room. And this is a bad practice, and it wouldn't be one that we'd recommend and would probably get a regulatory citation. So we're really looking at hatches, automated chambers, or autoclaving, and the focus here is with the hatch transfer disinfection process. So I'll hand you back to Helen.
Thanks. So going back now to the case study that we performed around material transfer. So I just want to take you through the elements that we capture within that process. So this review of all the individual steps that need to take place to have a comprehensive material transfer approach in place. So one of the items, the elements that we look at is thinking about those specific individual items that are entering and considering the packaging of those items. So how are they arriving at the point of entry to the classified areas? So thinking about things like the presence of wooden pallets, because that's a potential source of spores, or cardboard similarly, but also thinking about where the final destination of that item is, and is it appropriately overbagged with a number of layers to protect it as it moves through the transfer process? Because one of the key steps in protecting items is delayering them as they move through the process. So you're reducing the surface contamination risk by removing a layer before it passes through into the next grade. So we stepwise look at what's the approaches to how packaging is handled for the items that need to enter the facility. And obviously monitoring is very much highlighted in the glossary, the definition of CCS that Tim presented right at the start from the latest available draft of the annex, because that is your feedback. That's giving you your kind of direct evidence of what is the bioburden that's associated with this process, and helping you to identify what are the action steps that you need to take, which disinfectants you might need to use to address those contamination risks. So thinking about from an environmental monitoring perspective, what kind of data do you need to be gathering of that bioburden, of that risk of that transfer process? So what's your strategy for that monitoring? Where are you performing that? Is it aligned with the items that are entering the facility? Do you do any specific bioburden monitoring of particular items that maybe you deem as high risk to get that real detailed understanding of what those potential sources of contamination are, and again, those risks that need to be dealt with? And then from a manual disinfection process, looking at what agents are in use. So taking a look at all through the stages, so whether you're transferring from the unclassified areas into classified, right the way through up to maybe going into the critical core of your process. So what are the principles of the disinfectants that need to be used, and have you demonstrated that those disinfectants are going to deal with the contamination risks that you have? And that demonstrating that that they are capable of doing that is obviously through validation. So looking at the validation process, have you got a robust validation package that's supporting the activities? Because the validation of disinfectant is a key requirement of Annex 1 as well. But it's not just about the items that go through every day. We need to think about when things potentially go wrong and you need to bring something non-routine into an area, because it's often the drift away from the norm that brings those greater contamination risks into a process. So if you're having to, say, for example, you've had a breakdown, you might need to bring a piece of equipment in, or you might need to bring tools into the area, thinking about what's the control of those items. Do you need to take any additional steps to manage those risks? Are you performing an upfront risk assessment of taking that item through? What are the steps you're going to take? Are you going to need to put any acceptance criterion to show that you've appropriately managed that one-off, non-routine activity taking place? And then also we need to think methodology-wise of, Tim presented then the different types of material transfer processes, from the automated through to the kind of manual disinfection steps. So if you are performing manual disinfection, how are you going through that process? We know it's really key that a disinfectant is in contact with the organism that it's trying to kill. So making sure that you are appropriately treating all of those items that go through that transfer process. You're getting the right application, you're getting the right contact time, so you are getting that efficacious disinfection process. So our assessment process steps through those 5 elements for material transfer, and individually assessing what's going on, what's your current state, and what are those the processes that you have in place currently. How do they line up to regulatory expectations or best practices around material transfer processes? So from our findings, what we looked at from the current state that we observed in the facility was that the first stage of the transfer, so the stage where you're going from unclassified warehouse to the controlled not classified area, was not considered part of the transfer disinfection process. And the risk around that is that's where you have more of your packaging materials, more of the potential of the cardboard. So from a disinfection point of view, your contamination sources potentially would be fungal and bacterial spores. So we need to think about how you're going to ensure that addressing those potential risks, so you're not bringing those through as you enter the classified areas. So making sure that you mitigate those risks early on in the process. So the likelihood of those being there is quite high. It's a completely uncontrolled area. So risk assessment wise, it's quite a high risk that contamination is present. but also sporicidal disinfectants was not used in the transfer disinfection process until the grade C to B transfer. So potentially those spores might stay present all the way through to them being dealt with at grade C. So you're just increasing that potential risk of them getting into the facility, being present. So it's having that strategy and thinking up front, okay, what proactive measures can I take in my process to mitigate that risk? So bringing that sporicidal disinfection early into the process. And if you do that, making sure that obviously you know the people that are going to be doing that activities, they're updated a procedure to do that, it's trained out, and then it becomes embedded into that process. Another area that we looked at was around the methodology. So there was no monitoring that of the wet contact time being achieved in practice. It was validated, very detailed, and provided in validation documents that there was a specific wet contact time was validated. But in practice, that wasn't being monitored. So the risk there is, without achieving the validated wet contact time, is not knowing necessarily that the disinfection process is going to be effective. So potentially could contamination remain on items that are being transferred. So say, for example, you've validated a 10-minute contact time, but you're only achieving 5 in practice, you might not be getting the bioburden reduction that you're expecting to see. Because that wet contact time, as I said, it is critical that the disinfectant needs to be in contact with the organism for that biocidal activity to take place. So if there's no measurement of the validated time in practice, then you're taking the risk potentially that you're not going to get that process effectively managed and the bioburden reduce. So the recommendation there is to introduce a process to ensure that that validated contact time is in place. And we often see that done, certainly with transfer hatches, with actually equipment controls. So often the interlocks on the hatch are aligned to the wet contact time. So you test that the airflow in there means that you can actually achieve for example, the 10 minutes you may have set as a contact time, and then you set your interlocks. So you load from one side, disinfect, place it into the transfer hatch, close down your doors, let the 10 minutes elapse before the door can be opened into the higher grade area that you're transferring to. But it also can be done by procedural controls and recording. Once an operator has applied the disinfectant to the surface, recording the time and then monitoring that time's elapsed. So there are different approaches you can take. Clearly, the more equipment-based controls are a bit more foolproof in that, but it's what you can introduce within your facility. And then finally, we looked at the environmental monitoring aspect, the understanding, that feedback of what's going on. And there wasn't any ongoing monitoring of bioburden associated with incoming items. So there was a one-off study completed just to get that a baseline of understanding of what potential bioburden needed to be mitigated as it moved through the facility. So considering if there's no ongoing monitoring performed, then are you missing changes in contamination risks, potentially, if different items are brought into the facility or changes are made? So you can't react to that. You can't detect them, and you can't then address those risks. So really thinking about if you've got a risk there of no feedback of the effectiveness of your contamination controls. So thinking, what do I need to put in place so I get that consistent picture of feeding back into my status of control and whether I need to take any activity to address any shift away from that status of control. So whether you consider introducing a periodic bioburden assessment of maybe high risk items that you see, potentially as potentially having a higher risk of contamination present associated with them. Or you could amend the strategy of your environmental monitoring program to align to the transfer of those high-risk items, so they can be your key indicators of how your contamination control strategy is playing out for material transfer. So that's just to give you as we said, we'd focus in on two particular areas. So around material transfer, the level of detail that we look at within the assessment process, but also helping you kind of see from your perspective what you might need to look at from a contamination control strategy, elements to consider, how you might step through that process and put actions in place to potentially address any gaps within your strategy. So I'll hand back to Tim now as we'll go through the second key area that we've reviewed.
Okay, thank you. So the second area is about residue management, and I think I said earlier that this is something which is becoming more of a topic being asked for about regulators, and it's kind of the next area as knowledge about cleaning and disinfection agents advances. So we have in the United States Pharmacopoeia chapter on disinfection, USP 1072, a concern flagged about the possibility of product contamination arising from disinfection agents, and this is something that can very much arise. I remember talking to someone who was at a company where a door of a freeze dryer had been disinfected and then closed, and some of the residues there had interacted with products. So these sort of interactions can occur at various places and at different levels, but there are also some other concerns about residues. So other concerns about residues are also that they can make surfaces sticky, and this stickiness is something that helps microorganisms remain attached to surfaces. Now, microorganisms generally can be found in two states in relation to this. They can either be disassociated from surfaces, as they might do in water, or loosely attached to surfaces, or they can be strongly bound to surfaces. And the tighter an organism is bound to a surface, then the harder it is to destroy it with a disinfectant. So we want to avoid unnecessarily attracting organisms to surfaces, and different residues are going to have different interactions with organisms, so we're going to get different physicochemical interactions. So we want to avoid this attractive ability that could exist. Another concern with residues is that the residues of one disinfectant can theoretically inactivate the next one that's applied without any attempt to address those residues, or without understanding the way that the chemistries are going to interact between the two agents. So we do need to be concerned about that as well. And then also there are health and safety risks as well, because residues are going to make floors more slippery or more sticky, and we're going to have concerns around operators. So we've got these three areas of risk to product, risk of microbial adhesion, risk of disinfectant inactivation, plus the safety concerns as well, which all come together. And the object of this slide we've presented here is we've got a variety of different surfaces, and each one of those has got a disinfectant residue on it. And unfortunately, our main way to assess residues remains visual. There is work underway to develop more sophisticated tests based around conductivity. But for the standard cleanroom operation, and from the point of view of the person undertaking the cleaning or disinfection, then it's the visual assessment which is the key thing. And you can see from here that on some surfaces residues are easier to spot than others, but even where residues are easy to spot, the appearances are quite different as well. So we have a new layer of training and education considerations for clean room operators, as well as understanding the various risks that residues are going to be presenting to us.
So going back now to our case study, so now we're looking at residue management. So as I went through before with the material transfer process, the elements that we now want to consider within residue management are thinking about what are the agents being used to manage residues within the area. So again, are they the appropriate agents in place? Are they going to remove those residues off the surface? Are they appropriate for use in a GMP environment? Taking those things into consideration. And then also the methodology around residue management. So what's the assessment process? Is there a strategy in place to remove residues on a routine basis? And then practically, how are those residues being removed? And then also thinking about what's the documentation supporting that. So considering the not just the procedural aspect, but the training around it, and also the capturing that overall strategy in that assessment process. So when we look at the case study, the area that we identified for residue management was that the current state around the removal of residues was that there wasn't actually a residue step being performed during the rotations. So very good practice in place that disinfectants were being rotated, so more than one type of disinfectant was in place, and also good practice that there was a separate cleaning step with a detergent used. But between the transfer of those transitions of those different agents being used on the surface, there was no residue removal step. So as Tim alluded to before, the potential there that you've got that chemical residue on the surface, there is that potential of some sort of chemical interaction. And from a contamination risk point of view, if that results in the inactivation of a disinfectant, it could lead to contamination being present on the surface. And also, there is that additional safety risk to consider of chemical interactions. You know, I have been aware of in a facility there was no residue removal being performed, and their sporicidal rotation was actually chlorine-based. And they did see, when they made a change in their disinfection process, that they started to get chlorine gas coming off the surface because of the chemical interaction. So clearly quite a significant safety risk there. So you do need to consider, although, you know, we're talking about the principles of contamination control strategy, but, you know, the majority of the time, the disinfection cleaning process is manual, and, you know, human beings are put there in front of those risks of those chemistries. So we do need to consider that as well. So from a mitigation point of view, it's thinking about the appropriate rinsing steps that need to be performed in between rotating different chemistries, detergents or disinfectants, to making sure you're returning that surface down to a clear, fresh surface to apply the next agent onto. So you need to think about, you know, what are the different types of chemistries, and seek advice, you know, from your suppliers of these products to find the best type of solvent that will remove those residues off the surface. You know, clearly, aqueous-based disinfectants, for example, you know, water might be the most appropriate to lift those off the surface. But it's important that you understand what those chemistries are and do define the appropriate agent, solvent, sorry, to remove that off the surface. So thinking about, you know, the strategy, the contamination control strategy around residue management, it's having that structured view of what's going down on each surface, what are the risks that are there, and making sure that your management plan addresses those risks proactively. So that concludes the focus onto the case study of the areas that, you know, that we reviewed. We just wanted to talk about some general best practices for contamination control strategies around cleaning and disinfection. And as I mentioned before there, when we did the review of BPL and looking at that rotation, what was in place for their disinfection approach, you know, it really is important to make sure that you've got the right rotation of disinfectants within your facility to address the breadth of different type of contamination that could be present within there. But as you know, as I talked about before, with the different chemistries that are available in that example around chlorine, those more aggressive chemistries that are typically your oxidative chemistries that are sporicidal, is making sure that you're using those at the appropriate frequency to mitigate those sporicidal risks. And if you've got good contamination control principles in place, you should be able to use those more aggressive chemistries at a lower frequency. Or you could even replace that sporicidal manual disinfection with potentially automated decontamination using hydrogen peroxide, which has although you can't be present when that's happening, which is a good thing, it breaks down into water and oxygen, so much safer from that perspective for the user once the decontamination's been complete. And disinfection is a requirement to validate disinfection, but it's also really important for yourselves that you do get that evidence that you are getting the contamination control, that the disinfection is being effective in your facilities. So it's important that you step through that validation process to get that assurance up front that you've selected the right products, that you're using them at the right frequency, and that your rotational strategy is effective as well. And one of the most important things for manual disinfection processes is making sure that the application technique is consistent, because you do need to make sure you get that full coverage on all the surfaces, whether it's a surface of an item being transferred or it's a floor or a workbench, is making sure you get that full coverage of disinfectant to make sure that where bioburden is present, it's getting the appropriate contact with the disinfectant agent for the appropriate time. So really important to support your cleaning and disinfection teams with appropriate procedures and really structured training so they understand the importance of doing that consistent process. So just reflecting in summary there, we've talked about contamination control strategy, how it forms this really key feature of the revision to Annex 1. And it's an excellent process to systematically look at the contamination risk, be proactive, design it into your your ways of working, so you're upfront, you are managing those contamination risks. And we've given you an introduction there of how we can use the Ecolab assessment tool to really systematically look at those risks associated with cleaning and disinfection. And then once you've done that assessment process, it's about implementing the appropriate strategy. So you put those planned set of controls in place to manage those risks. So that concludes our presentation. I hope you've all enjoyed listening to that.